Greetings, salutations, all those nice things. Welcome to math class. We are getting into our 11th topic out of 12. We're on rational functions. There is going to be a few things involved with this. We're going to, for this first part anyways, be relying on our ability to transform existing functions, transform them from their graphs, and develop their equations. We're also later on going to be relying on our knowledge of polynomial functions, how we graphed those, how we found their zeros or critical values, the sign diagrams. At some point you'll probably also have to learn how to factor. Hopefully you still remember that from every single other time we've done it. And even though it's so last year, you will have to solve rational equations. That is totally testable. Anyhow, let's dive in. Rational functions are written like this. It's a function over another function. So polynomial functions being divided by each other. And of course, because there's a function in the denominator, we have the potential for restrictions. Because we can't divide by 0. Dividing by 0 is bad. It's frowned upon. People have been punished for lesser crimes. The function y equals 1 over x is something you would have seen last year as our basic reciprocal function when you did reciprocals of linear and quadratic functions. We know it has invariant points because if your original function y equals x just kind of follows this line here, that line there. Am I even straight? Do I even know? No, that's completely wrong. There we go. There is my point. Then we have those intersections where the original was at 1, 1 or negative 1, 1. The reciprocal is the same. Because the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. That's that business. They provide our key points. So this point 1, 1 is a key point on this graph. And this point here, negative 1, negative 1, it's a key point on the graph too. The other two keys in this, they aren't points, but the asymptotes. We've got a horizontal asymptote here, right on the x-axis that has the equation y equals 0. And then we have our vertical asymptote here going up, down, right along the y-axis. That's got equation x equals 0. So those are all the keys that we're playing with. And when we did transformations, we knew that we could stretch or compress things horizontally, vertically, and we could move things around, up, down, lefty, righty, all that jazz. Now, interestingly enough, because of this original shape, if we were to compress things horizontally or stretch things horizontally, we could actually phrase that as a vertical transformation just based on the shape. And we've seen that with some other functions too. So really, we're going to ignore this b value as if it's not there. As such, our transformations of this function will look like this. And drawing on our knowledge of transformations, that means we know that a is a vertical stretch factor. How much are we multiplying the y values by? H is how far we're moving to the right. And k is how far we're moving up. So that's that. That allows us to transform the key points, but let's also make sure we can transform those asymptotes. Originally, we had one that was x equals 0. That was our vertical asymptote. And when we take x equals 0 and shift it h units to the right, we add h to it. Well then, 0 plus h is h. Blah. For the horizontal asymptote, y equals 0 was the original one of that. We're going to be multiplying it by a. We're going to be adding k. 0 times a is 0. 0 plus k is k. So these are the asymptotes we're going to have when we transform that function. And then the key points for the x values, we're just adding h. So 1 plus h is 1 plus h. Similarly here, negative 1 plus h is negative 1 plus h. For the y values, we're multiplying by that vertical stretch factor, and then we're adding k. So 1 times a is a, and then we're adding k. Negative 1 times a is negative a, and then we're adding k. So there's our mapping. We're going to use, close that bracket. We're going to use this information to draw these graphs. Shouldn't be the worst thing in the world. But if we can plot these key points and we can draw those asymptotes, we can really get the rest. That's all that's really necessary. We should be able to also find intercepts if they exist. We're just remembering that if you want an x-intercept, let y equal 0. If you want a y-intercept, let x equal 0. All that business. Let's get to it. Ciao! Whoop, too far. All right. We're going to sketch this function. We're going to label the asymptotes. We're going to label the intercept. It's going to be pretty wicked. Let's find everything out. There's a whole bunch of orders you could take this in. How would I do? I'd probably start by noting what my asymptotes are. I can write that full word. I have that skill. So a vertical asymptote is going to happen at x equals negative 3, since we've shifted 3 left. And our horizontal one, we've multiplied by 4 and then subtracted 2. So there's our horizontal asymptote. At this point in time, I kind of like to start drawing. I like to draw my asymptotes, which means I'm going to kind of need a scale on this thing. I'm using a ruler just so we're all clear. Don't just be like, yep, there's some tick marks, we're good. Like, please take some sort of measuring device where you can have nice and evenly spaced lines. Tick, tick, tick. Feel free to fast forward me drawing all these tick marks. I'd be offended, but I won't know. Doo-doo. And in fact, just to save myself a bit of time later, I'm just going to copy those over to here. Feel free to copy and paste the exact same way. Center that thing. Perfect. You know what? I'm just going to keep going. We've got a lot of graphs to get through. Can't dilly-dally. That it? That's all the graphs? Alright, we good. Enough with tick marks. onto those, asymptotes. That's not a point. That's not there. So vertical asymptote, x equals -3. I'm going to use my trusty ruler again. I'm going to draw my asymptote. Ooh, I have colors. Don't forget to label your asymptotes. It's kind of necessary. It's a communication error if you don't. It's very sad. I mean, in my opinion, as long as the scale's indicated, which it's not right now, but we will. But as long as that scale's indicated, you should be able to tell what that asymptote is. But rules are rules, and I don't make them. So we got that. And draw other asymptote. And I'm pretty sure this has an equation too. Boom. Asymptotes done. I'm also going to get my key points. So let's figure out where the point 1, 1 went. And let's figure out where the point -1, -1 went. Transform those. Remembering that we do some stuff. This stuff. Add h to the x values, multiply by a, and add k to the y values. Okay. So the point 1, 1 is now -2, 2. And the other one is -4, -6. And there's still more to do, like there's more points to find, we have to find the intercepts, but I like to plot things as I find them. So I know this point is at -2, 2, which is like here-ish. And I know this other point is at -4, -6. Where do you think -6 is? 1, 2, 3, 4, 5, 6. Right there. Okay. All right. We've got these two key points. We've got our asymptotes. We are also asked to find these intercepts. So let's get those. Y-intercept happens when x is 0. -2/3, that's not even a whole number. My goodness, it's probably like about here. About 2/3 of the way down-ish. And then x-intercept. Oops. Where y is 0, and we solve for x. Alright, we've got some points. Wicked cool. It's worth noting that there will be a symmetry to this function. It's a rotational symmetry. If you rotate 180 about the shifted origin, where the asymptotes meet, you'll get same thing. So where we went right 1 down 2 to get to this other point, that's the connection between these 2 points. Help. So right 1 down 2. Rotate that, we can go left 1 up 2 to get to another point. Right there. And that's because of that symmetry factor. That's if you want to draw that other point. It's not absolutely necessary. I like to. I like to have as many points as I can possibly find. Any poops. We're now going to play connect the dots. Where do these dots go? I mean, like, these ones clearly connect like that. We need that much in there. But then what? What does this do? We should always trend toward the asymptotes as we approach them. So this goes up here. Woo-hoo! And on the right side, this thing's pretty much done. So it's just going to keep going on forever, ever. And if it's at the point where it's going on forever, ever, then it should trend towards this horizontal asymptote. Similarly, these 2 points connect. Not a straight line. That's ridiculous. But a nice curvy-wurvy line. Also known as a curve, not a line. Don't get confused. Trends towards the asymptote there. And then it should do same on the left side, trending toward that horizontal asymptote as x approaches negative infinity. Things worth noting. I mean, I'm not particularly picky about it, but don't just do one big old line and be like, this is my curve. Like, actually try and make it look moderately pretty. You'll notice I use my like sketchy line style, where I'm kind of doing things in pieces. So there's some graduality to it. That's the way you want to do that. Make sure it looks beautiful. I hear that. It's ugly. And that's how to graph that one. I dare you to try the next one, and then we'll move on. I mean, I'm going on anyways, so pause, whatever, rewind, whatever you need to do. I'm going to start this right away. I'm going to get my asymptote. Just the one asymptote, actually. Y is something. 3. Wicked. I'm going to draw those things. Ruler. Or like at least some sort of straight edge, you know? Don't just be eyeballing this. I think these graphs look gorgeous. Show that you really care about them. 5 is 3. I see where that is. Oh, everyone, you know what I didn't do? I got a communication error on the last question because I didn't label my scale. Oh, what an amateur. I didn't even label the intercept. Okay, let's just label these dots somewhere. Let's go. This is 5. And this is 5. Wicked. And we got some points here too. This point is -1, 0. This point here is 0, -2/3. Super duper. Now I did everything. Man, I lost so many marks. Rough. Anyways, let's label these asymptotes. Okay. Wicked. Oop, oop, ah. Find my key points. Ta-da. We already have the y-intercept. It's right there. We stumbled on it just by the nature of where that key point went. Wicked cool. So don't really need to find that again, but we need to find our x-intercept. Where is that located? plus 1. What's 1 these days? Like 3/3? Alright. Ah! 5/3. What's all the fractions? Who made these questions? Just ridiculous. Anyways, that's a little less than 2, right? So I guess we're kind of there-ish. That's what we got to accept. Alright. We've got 3 points. We're ready to play connect the dots. Note that this point here, when it trends toward the asymptote, is not going down this way. This thing's already in positive land. Let it just stay there. It's not going to move toward the other points. Trends towards that asymptote. Trends toward this asymptote. I mean, it'd be a real lumpy figure if you try to make a trend toward this asymptote and have the other end go down. Same, like this isn't going up here because that's going to be weird for it to come back to this asymptote. There are functions that do that. Not these ones though. So we connect those dots. We reach this vertical asymptote in the middle. And then we go towards this horizontal asymptote up here. Wicked. And just so I get all the marks, oh man, I'm going to label so many things. I'm going to label this point right here, that's at 0, 5. I'm going to label this point over here, that's at like 5/3 and 0. And, oh man, I'm going to label my scale 1, 2, 3, 4, 5, 6. Let's label this 7. That seems like a good number. What's this, 2? Wicked. This thing is done. So that's transformations of 1 over x. Great function. I'd say it's in my top 100. We can also transform 1 over x squared. It has similarities. It is a little different. It looks like this. X squared is never negative, so its reciprocal is also never negative. So this thing is entirely positive. Always above the x-axis. It still has the same 2 asymptotes. It has the x-axis and y-axis as asymptotes. And key points wise, I'd be looking at this key point of 1, 1, still there. The other one though is -1, +1. So different, just slightly different from the last one. That's what we're transforming, and we operate the same way. So we'll find our asymptotes based on the transformations. We'll find our key points based on the transformations. We'll find intercepts. We'll do that manually though. And then we play connect the dots. And like so. Woo! Look at this. So this thing has shifted 3 to the right. It shifted 4 down. And that's what we'll be operating with. Asymptotes wise. Why did I switch to purple out of nowhere? Come on, man. Where's consistency? So vertical asymptote was x equals 0. Now we've shifted 3 to the right. So there's that. This was y equals 0. We've shifted 4 down. So close. 4 down. There we go. Key points. Shifting 3 right turns the x value into 4. Shifting 4 down. Oh wait, multiplying by 4 and then shifting 4 down. So take that y value, multiply by 4, subtract 4, you get 0. Similarly, -1, 1. We'll get, okay, shift that thing 3 to the right, x value is 2. Multiply by 4 for the y value and subtract 4, it becomes 0. Well, that's kind of handy. We seem to have just immediately gotten couple of intercepts there. If you wanted to manually find those algebraically, you still can. Why not? Why not? X-intercept. Try again. So we can solve for x in this. It's fine. Do some cross multiplication action. 4 over 4 is 1. 2 possibilities here. And solve each of those cases. So 1 is 4. Oh, 1 is 2. Same as these values up here. Anyways, we need a y-intercept. Just remember this part was super unnecessary. Oi. Yeah. Guess we're dealing in ninths. Negative 32 over 9. What kind of number is that? I don't know. It's somewhere between negative 3 and negative 4, though. Like halfway-ish. It's in that neighborhood. Well, that's what we deal with. Life's crazy. Let's draw my asymptotes somewhere. And other more different asymptote. Honestly, I don't like that I'm slightly off here. And I'm just going to redo that. It's not that we have to be perfect, but any obvious errors, might as well fix them. Let's just be the best we can be. Asymptotes exist. Points. Boop. 4, 0, 2, 0. And that's all our point. Yup. Y-intercept of negative 32 over 9. Again, about halfway between negative 3 and negative 4. Plot that to the best of our abilities. Kind of there-ish. Alright, connect the dots. Where does this one go? Up, down? It's gonna, as it moves to the right, it's gonna trend up. We'll finish that after. I'm just gonna connect it to my dot down here. Ugh, I could do way better in every regard of my entire life. Yikes. Undo, 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 undo. Alright, let's give this more of a swoopity-doo. Oh, there we go. That's a good graph. Woo! You can't see me doing this, but I am rotating my device as I do this entire drawing, just to make it real easy to draw my curvy curve lines. And by my curvy curve lines, I mean my curvy curve curves. My apologies to mathematical purists everywhere, because lines aren't curves or something like that. We'll note some symmetry here. They look kind of same. they're mirrored over that line. Where the previous one, 1 over x, had rotational symmetry, where it rotated over a point. This one has line symmetry, so it's got a reflective point. This side should mirror this side. We're oh so close to being done. I always do this last just because that way I can place my numbers where they won't interfere with other aspects of the graph. Anyways, there's 6. Here's 2. Right, because you can label these anywhere. Here's 1, there's 2, there's 3, there's 4. But I do not like conflict between the things I'm writing. Oh! Should probably label these intercepts. Boom. Let's try this next. Whoa! What is this? That doesn't look like the above example at all. Is this a trick being had? Oh, now that I think about it real hard, like, I realize that's probably factorable. This is like y equals 2 over x plus 2 squared. Woof! Good thing we recognized that with our 6 skills. Otherwise, we would have been all sorts of lost. Wow! Close call. All right, try this on your own, real quick. Pause video, all that jazz, blah, 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 blah. Because video-wise, this thing's going ahead. Man, this is a long lesson. What did I write glass into it? What did I do? 2 left? Why am I struggling with sets today? We went 1 up. Bloop. My key points. One half plus this is like another 2 halves. All right. And my x-intercept. There are things you might note about this before you go about trying to find the x-intercepts. It's worth noting that we generally have this shape. That's the original shape, this nice little volcano. It is possible to have upside down volcano, but that's if we have a vertical transformation that causes that, like a flippy-do. This does not have a flippy-do. Our A value is positive. So we have our volcano. This thing's got an asymptote that goes this, dot, 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 dot. And then this whole thing is shifted up 1 unit. Well, if the asymptote here shifted up, and that asymptote was the axis, there's no way we can hit the axis. So in theory, we should not have any x-intercepts at all. You want to prove that algebraically? Go for it. Don't have to, but go for it. Y is 0 when x is what? Okay. Do that cross multiply, divide, add, all that jazz. X plus 2 squared is 2 over -1. Seems questionable. What? Something squared is -2? That doesn't make sense. You can't square something and get a negative number. Not in the real world. Maybe in some sort of complex or imaginary land, but not in real life. So there is no x-intercept. You can be sad about it. Yeah, it's kind of almost a neutral sad. Now, let's draw this. X is -2. It's like over here. Y is +1. Alright. Those are labeled. Let's get our points. This point, and the remaining point we have is the y-intercept at 3/2 or 1.5 right there. And it does mean that there's a mirrored point over on this side of the line, if you want that there. I kind of like it. I'm going to put it there. And then, connect the dots. These going down? No, they're not. The ones that are closest vertical asymptote will squeeze in close to it. And then, whoa. And then to the others. It goes down. And it goes up. That one is done. So those are examples of graphing transformations of y equals 1 over x squared. The final thing we're going to look at in this doozy of an introductory video to this topic is rewriting equations. This is actually the form that we'll probably more often see polynomial over polynomial. So not with this tail end k business, but just one poly over another poly. In this case, binomial over binomial. And that's what we'll be more used to playing with later. But it is necessary, it's useful to be able to convert between the two forms. On the bottom of this, we're dividing by x minus 2. We need to split this up into two pieces. A whole component and then a part that can't be reduced. Thing is, there's no common factors between top and bottom here. So what we do is we act real sneaky. We say, yes, there actually is an x minus 2 up here. It's right there. It's there the whole time. Except to compensate for throwing this -2 in there, we have to throw that +2 in. So we're adding 0 to the numerator. We add 0, we're not changing its value. So this is how we've been sneaky. We subtract 2, we add 2. We do that because that gives us this piece, which is same as this denominator. That's that jazz. In having that, we can split this up. Right down the middle. We have two pieces. There's this piece. X minus 2 over x minus 2. And then there's this piece, the 2 plus 1 over x minus 2. Just how we play with fractions. And the advantage there is that now we have a piece that reduces. Huzzah. And we have this other piece that doesn't. So just simplifying the 2 plus 1, we have our 3. X minus 2 divided by x minus 2, generally speaking, is 1. And then finally, just to have it in that organized form, a over x minus h plus k, we just swappy-do the order of these two terms. That is how we'll be operating this. Feel free to give this a try before I do. I mean, technically in terms of just how time works. I've already done this by the time you're watching the video. So you can't beat me. I'm unstoppable. But you can, just attempt it yourself and see what happens. I'm going to roll. Y is equal to... Oh, I wish it said x minus 3 upstairs here. Okay, x minus 3. Ha ha ha. We can't just do that. I should add 3 to compensate. Okay. So there's that. There's that key thing of minus 3 plus 3 just to compensate for what happened down below. I break it up. First half, and then plus 3 minus 5. Super duper. Whoa, slow down there. X minus 3 over x minus 3, generally speaking, that's 1. And then this thing, the only thing we can really do is say what 3 minus 5 is. That's like negative 2. And last thing, I'll rearrange these terms. Boom! The end. And this other one was... Oh! So what are you supposed to do here? Say like 2x plus 4? That doesn't work. This isn't divisible by 4, or by x plus 4. Ugh. Yikes. Scary business. Bunch of ways to handle this. The way I will handle it is to put the x plus 4 in these brackety brackets here. Oops. But compensate there. It looks a little weird, but in that process, we can keep this 2x plus 4, and then take this negative 4 that does not belong in those brackets. How did you get in here? Who let you in? Just kick it right out of there. But noting that it's being multiplied by 2. So it's kind of like a partial distribution, if you will. And now we can do all the rest of the steps. We split this up into piece number 1 and piece number 2. We simplify as much as we can. Generally speaking, 2 times x plus 4 divided by x plus 4 is going to be 2. And then 2 times negative 4 plus 3 is like negative 5. And finally, rearrange these terms. Whew! What a doozy of a lesson. Can you imagine if we taught this in class? That would take up way too much time. I think in future I'm going to have to split this thing up. That was long. If you made it all the way to the end of this video, congratulations, because the vast majority of the world population has not. So you're beating billions of people in that particular regard. You've earned yourself not just a pat on the back, but maybe even a cookie. Or whatever your preferred snack is. Go for it. Maybe a glass of water. Ooh, I'm going to have a glass of water as soon as this is done. My mouth feels like cotton. Or like I've eaten a whole box of Triscuits or something. It was rough. That's that. Do this practicey work. Which, ow! It can be handy. You don't necessarily have to do all of it. Balance your time, balance your load, all that jazz. But make sure you're kind of secure with this form of a rational function. And we'll see you in the next video. Bye. Stop.